Okay, so nitrogen, how many electrons? 7. Phosphorus? AS has 3, and antimony, I think is SB, right? Is okay. All right, so now let's label again which intermolecular forces each one has, because that kind of helps. So when we think about NH3, okay, if you want to, you can kind of draw them off to the side. So, does this have hydrogen bonding? Yes, because a hydrogen is attached to N. So it has hydrogen bonding. Is this a polar molecule? Oh yeah. Yep, definitely polar, so it has dipole-dipole. Does it have London dispersion? Of course. Okay, let's do the next one. pH3. So all I change is that there's a P here. Is this hydrogen bonding? No.
Didn't you say it's hydrogen bonding if it's N or B?
N or F. No. Only these 3. And you can think about it, remember, we know that fluorine is the most electronegative, and then these are its friends that it hangs out with. Right? Okay? So P is not hydrogen bond, pH3 is not hydrogen bonding. Is this a polar molecule? Yes, so it does have dipole-dipole. And it has London dispersion because all molecules do. ASH3, hydrogen bonding? No. Dipole-dipole? Yes. London dispersion? Yes. And the last one, dipole-dipole and London dispersion. Okay, so look at this. This one starts at minus 33, okay? And then it goes back down to minus 87, and then it increases, okay? So this one is kind of a weird one.
Is it because your hydrogen bond?
It's because of the hydrogen bond. Very good. So this one is kind of an outlier because it has that hydrogen bond and it's so much stronger. So it's pretty high boiling point for being the top of the group, right? It doesn't have the amount of electrons, so it has lower London dispersion, but it has that hydrogen bonding, so it's very strong, okay? So that explains that, and then you see the similar pattern in the rest, okay? And then, so why does this increase as I go down? Because my electrons are increasing as I go down, okay? So these are the patterns that I want you to see as you go through this. And also, you're going to actually take these numbers, okay, and put it on the graph. Okay, you're going to graph this, and that kind of helps you to visually see the patterns that are going on here. Okay, so that's kind of that one. And then the next one, you're going to be graphing it here. And then here's the questions that kind of are asking you things like I just went through with you. So it says the hydrogen compounds of group 15, 16, and 17 elements have increasing van der Waals forces. Sorry, I should have told you this before. Van der Waals forces includes things like dipole-dipole and London dispersion. So. Okay. And hydrogen bonding. It's basically, van der Waals forces is another way to say intramolecular forces. You should have learned van der Waals forces like in junior high, just that term, but it didn't tell you hydrogen bonding, dipole-dipole, London dispersion. I told you. Okay. And so then it says, explain why the first hydrogen compounds show a reversal in this trend. That's just what Matthew pointed out. The first one that we see, oh, sorry, it went weird. But the first one doesn't follow the trend because it has that hydrogen bonding.
So it would need to be a higher boil.
Pardon?
So it would need to be a higher boil.
Yes, because it has that very strong intermolecular force, it has that higher boiling point. Yeah. Okay. So that's what those questions would be kind of taking you through. And then it says, why does CH3 not show this same trend? Well, same we kind of talked about. You look at the intermolecular forces that it has. And then here, the next page, you go through and do something very similar, okay? But you're not looking, yeah, it's very similar. So you fill in your number of electrons, and then here I actually give you what it is. So say you look at F2, okay? So we have our F2. Is this has hydrogen bonding? No. Is it polar? No. So it doesn't have dipole-dipole. Does it have London dispersion? Yes. So you can just put like a check mark in that spot, because that's all that it has. And so then that will kind of help you group everything too. So this type of assignment is challenging because you're really having to apply your knowledge. It's not just like memorizing a definition, but it's applying it to kind of a new situation and scenario. So this assignment, pages 1 to 5, I think it is, of your new workbook thing. Okay, so I didn't number it, but so here, and then this part. Okay, where it starts at chemical bonding review, that's studying. Okay, that's kind of getting ready for our unit exam. So up to the chemical bonding review is homework for Monday. Okay. It seems like a lot of pages, but it's just looking through patterns, right? You're looking at patterns. And once you kind of get going on it, oh, sorry, no, it's due Tuesday. I'm sorry, it's due Tuesday. Yeah. Okay? So you have a bit more time. Yeah. I will be doing some new stuff on Monday, but I'll try and give you some time on Monday to kind of work through it. And you have the rest of the class today to do it too. Okay? Yeah. So is it clear what's due? So Monday, it's the workbook that we have been doing, and then Tuesday, it's this new boiling point stuff that's due.